Hi again. In this lesson we're going to be adding vectors using components instead of using scale diagrams. So scale diagrams are nice because everybody knows how to draw and measure, hopefully, in this course by now. And so you can just measure your vectors, use a protractor to make sure they're all going in the right direction, and then you're going to get at least close to the right answer if you are very precise with your drawings. But a difficulty about that is that it's sometimes difficult to be perfectly precise with your drawings, and so everybody may get a slightly different answer when you are using a scale diagram. And so it would be better if we didn't have to rely on people's drawing skills or measuring skills to figure out how to add vectors together. And that's where components comes in. Components is a purely mathematical way of adding vectors. And so since we're just using numbers, then we don't have to rely on other sorts of errors that creep in, like difficulty measuring or drawing at a slightly wrong angle or something like that. So what you need in order to do components correctly is trigonometry skills. And just the basic ones, right? So sine, cosine, tangent, you need to be able to do that. Okay, but this relies on the fact that when you're adding two vectors together, you don't actually need to worry about what order they're being added in, right? And so if we add up a vector going this direction and then a vector going this direction, the resultant is here. But that's going to be the same as going first this direction and then this direction. Then if we're drawing of our resultant vector starting from the beginning and ending at the end as you do things, it looks something like that. If I had drawn them both perfectly, this vector here and this vector here would be exactly the same. Since it doesn't matter which order vectors get added in, all you really need to know is how far sideways am I going, or how far in the x direction, and how far up am I going, or down. How far in the y direction am I going. So as long as you can take all of your vectors and figure out what's the x part of that and what's the y part of that, then we can use trigonometry to put those together. Okay, that's going to make more sense in a moment. So here we go. The first thing that we need to be able to do is break a vector into just x and y components. So adding vectors that are angled like this one over here is difficult because there's an angle involved with it. But if it was just sideways and up and down, then those are easier vectors to add because we can do it with trigonometry. And so this vector, here's its beginning point, here is its ending point, and so to get from beginning to end, we've got to go this way till there, and then this way till there. And so this would be called the x component of this resultant vector, so the total one is called your resultant. This is the x component, and this is the y component of your resultant vector, okay, or of your total vector. And the 22 degrees goes in here. So the angle between the x and y components is 22 degrees. And so when we calculate the x component, how far are we going sideways and how far are we going up and down? Or let's go with our compass directions. How far are we going east in this case and how far are we going north in this case? Then we just use trig to do it. So let's talk about the x component first. In order to figure out the x component, if I am considering this angle over here, this 22 degree angle, to be my reference angle, and that means I know the hypotenuse, and I'm looking for the adjacent side. The y side is the opposite side, right? And so the opposite side is not involved in this particular calculation. And so I need to use adjacent and hypotenuse. That's cosine. Okay, so cosine of 22 degrees equals adjacent divided by hypotenuse. And in our case, the adjacent side is x, it's our x component, divided by our hypotenuse, which is 7 meters, 7.0 meters. Okay, so this is not meant to say x divided by cosine 22 degrees. I've just put them a little bit too close together. So this is cosine 22 degrees is equal to x divided by 7. So now we need to solve for the x part. So we're going to multiply by 7 because it's currently a divided by 7, right? So to remove the divided by 7, you multiply by 7. And what we do to one side, we also have to do to the other side to keep the two sides equal. And so we're really doing x is equal to 7 times the cosine of 22 degrees. And when you do that, you get 6.5 meters. And this is a vector, so it needs a direction. And in our case, this one is east. Okay, so you need to decide which trig ratio am I using. And then you're going to need to do some algebra to get the unknown by itself. Thankfully, it's pretty well always the same algebra steps if for some reason that is a difficult part for you. So now we're going to do y. And y is opposite and hypotenuse. In this case, you could use tan because we have solved for the adjacent side right over there, but it's best to use the given side to solve for your unknown because it brings less rounding into your calculation. So it would be best to use sine. Sine of 22 degrees is equal to opposite over hypotenuse, so that's y over 7 meters. Okay, and again, we're going to multiply both sides by 7. It's the same algebra step, and it pretty well always will be. So we're doing this 7 times the sine of 22 degrees equals y, and in our case, 2.6 meters north. So that's what you need to be able to do in order to work with components. You need to be able to split an angled vector into its perfect x and y components, and then later on we're going to put those back together using the Pythagorean theorem. So let's add these three vectors, for example. First of all, let's notice that this 3 Newton up vector over here, this is a y component. There's no x component to it. It's not an angled vector. So we don't need to do anything to that one. We can just use it as is. Because what we're trying to do is make sure we have all of our vectors changed into their individual x and y components. So that one's done. This 5 Newton vector is an x component. So we don't need to do anything to that either. But this angled one over here, this one is a combination. And so if we start at the start and end at the end, we have to go east, and then we have to go south. So this resultant vector over here is a combination of an east vector and a south vector. And so that would be x and y. Thought I was going to sneeze and didn't, so that's disappointing. Let's figure out what the x component and y component are of this vector over here. Because once we have done that, we can add the x's up, we can add the y's up, because those are totally possible to do, and then we can make a composite of both of those. So here we go. This x component, because this is the 30-degree angle. Okay, I realize that 30 degrees isn't quite as far into that corner as we'd like it to be, but that's what we're talking about. X is going to be cosine again. So this is cosine of 30 degrees equals x over 2 newtons. And then we're going to go 2 times the cosine of 30. And so x is going to be equal to 1.73 newtons, and that's in the east direction. And then y, I'm not going to write the whole thing out this time. because I know that I'm always going to be multiplying the hypotenuse by the sine or cosine of the angle, I'm just going to go right there. So this is 2 times the sine of 30 degrees. The sine of 30 degrees is 0.5, so 2 times 0.5 is 1 Newton, and that 1 Newton is going to be in the south direction. Okay, so now instead of this angled vector over here, now what we have is a 1.73 in the east direction, and we have a 1 in the south direction. We have a 1.73 in the east direction and a 1 in the south direction, and these are all newtons. Okay, so now we can look at all of the x values that we have. So the 5 newtons over here and the 1.73 over here, those are both x components. We can just add those up. They're both to the east, and so we've got 5 newtons east plus 1.73 newtons east, so we'll get 6.73 newtons east. Let's just make an x components heading over here. And so what we're doing is 5 newtons to the east, and I'm adding on to that 1.73 newtons to the east, and so my total x component is going to be 6.73 newtons to the east. That's how much pushing there is in the east direction. Then let's do the y. So y is going to be slightly different because we've got 3 newtons north and we've got 1 newton south. So I wrote a plus sign in here, not because I'm going to add 3 plus 1 is 4, but I'm adding 3 north and 1 south. You can also think of that as subtracting 3 north and 1 north. Okay, but either way, you're going to end up with 2. Okay, you probably knew that just intuitively, but that's what you're doing. So 3 north plus 1 south gives you 2 north. So we end up with 2 newtons to the north as our total y component. Okay, now there's one more step to this thing because we want to know what the total is. So that means we need to add up 6.73 newtons east and 2 newtons north. We need to add them up, but we can't just add up vectors that are in different directions, right? We can't add x to the north or x to the east and y to the north. The only time you can add them up is if they're east-west vectors or north-south vectors. That's the only time. And so we need to add these up using vector addition. And here's what that looks like. We have our 6.73 to the east, and we have our 2 to the north, and we add them tip to tail. Now our resultant is going to be here. This is our total vector. Resultant is just when you add vectors together, that's your answer. And so we need to know both the size of this resultant and we need to know its direction because it's a vector. And so we need to know this angle. Okay, so we've got 2 pieces to do here. The first thing, because we know the 2 legs, this one and this one, we can figure out the hypotenuse using the Pythagorean theorem. However you want to say that person's name, but that's my favorite and the only right way. So I'm going to go 6.73 squared plus 2 squared and square root those things. If you remember, a squared plus b squared equals c squared. So the resultant is the square root of 6.73 squared plus 2 squared. That's just a squared plus b squared equals c squared and then square rooted. So the resultant we get is 7 newtons. Now I put a vector symbol on the top of that r, on top of the resultant symbol, because this needs a direction to it. And so I'm not quite finished here. I need to put in that direction as well. And we figure out that direction using trig again. So we know the 6.73, again, over here. We know the 2 over here. And so we can use opposite over adjacent. We can use the inverse tan to figure out what that angle is. So the angle we're looking for is the inverse tan of opposite, which is 2, over adjacent, which is 6.73. And so the angle that we get is 17 degrees. Now we need to make sure that we put compass directions on that as well, because that's not quite perfect. You can't write in 7 newtons, 17 degrees. 17 degrees isn't a direction. You need to start by saying where you're measuring from and end with where you're measuring toward. So in this case, I started measuring toward the east. That was my x component. Started measuring toward the east, and I measured my angle toward the north. And so our final vector direction should be east, 17 degrees north. And so our resultant vector direction and everything is 7 newtons east, 17 degrees north.